Now, looking at the first question that we have on the screen, I'm going to have to ask you to pause and read the question. So pause it and read your question now. So obviously, after doing that, you can see A is a diabasic acid of H2Y. That is, the acid is unknown fully in this scenario, and it contains 2.52 grams in 250 cm cube of solution. Obviously, so there's a way you can get the calculations of the concentration there too. B is 0.100 mole per dm cube. So after looking at all of this, after doing the titration of this particular question, our theta value will always remain 12.20 cm cube in all of my questions. So we are going to first and foremost calculate the conc of A in mole per dm cube, followed by the molar mass of H2Y, followed by the number of mole of hydrogen ions in 250 cm cube, followed by the number of hydrogen ions in 1 dm cube. So let's look at the equation that we have beneath. We have H2Y plus 2NOH is giving me Na2SO4 plus H2O. That is, the salt is Na2SO4. That is sodium tetrasulfate 6. And from the balance equation, it is easy for us to get the mole ratio of the acid to the base, because you have to look at the coefficient of the acid in the balanced equation. The coefficient of H2Y is 1 rather. That is, Na is equals to 1. While the coefficient of NaOH in the balanced equation is 2. That is, your Mb is equals to 2. So the mole ratio of acid to base in this question is 1:2. Now, if you proceed, you can now move to the next slide, which is the calculation to these questions. Now, in the first one, to get the conc of A in mole per dm cube, because there is no way you can convert, although there's a way you can convert 2.52 gram in 250 cm cube to mole per dm cube, to gram per dm cube, but there's no way you can turn into mole per dm cube because you cannot get the molar mass of H2Y yet. So because of that scenario, we are going to use the law of dilution of acid to base, and that is the CAVA over CBVB equals to Na over NB. The CA stands for conc of our acid in mole per dm cube. The CB stands for conc of the base in mole per dm cube. Your VA stands for your volume of acid used. In this case, the volume of acid used is my titer value, which is 12.20 cm cube. While the VB stands for the volume of the pipette that will be used. In this case, in my own laboratory, I have a pipette that I use. My pipette is 25.0 centimeter cube. That is, your VB is always in this kind of questions. Question 1 is always the volume of the pipette that is being used. And obviously, like I said earlier, my mole ratio of acid to base is 1 and 2. That mole ratio is very important to you state it out, even if you don't write every other thing out, because mole ratio will give you your 1 mark in this part. So obviously, I'm looking for CA, which is the conc of my acid, which is A in mole per dm cube. So I will likely make Ca the subject of my formula. My Ca will be equals to CbVb Na over Va Nb. That is after making Ca the subject of my formula. So then I'm going to put my substitution. For my question, I know that my Cb is 0.100 mole per dm cube, which is already stated clearly. My Vb is the volume of my pipette used. In this case, I'm using 25.0 cm cube. My Na is 1 for my balanced equation. That is the mole of my acid. Over my Va is the titer value. That is my average volume of acid that I derived after doing the titrations, 12.20. So multiply by 2. So at the end of it all, my Ca gave me 0.102 mole per dm cube. Now there's a must on something that you must do. When you are writing your answer, your final answer in mass and in concentration, your answer must come in 3 significant figures to score in Waec. So that is 0.102 mole per dm cube. Then obviously the next scenario is calculate the molar mass of H2Y. So like I said earlier, from what we have 2.25 grams of A in 250 cm cube solution, we can get the mass concentration. Now you may as well see the formula. The formula for mass conc is mass over 1 multiplied by 1000 over V. So the V here is not titer value. The V actually stands for the volume of the solution that was used. So the V is 250 cm cube because that was what was dissolved to make the solution. 2.52 in 250 cm cube solution. So therefore, my mass is 2.52 multiplied by 1000 over V. So if I should do all of it, I will get 10.08 gram per dm cube. But like I said earlier, in Waec, when they mark most of these things, your answer should be in 3 significant figures. So my 10.08 gram per dm cube now will be converted to 10.1 mole per dm cube. Now also another formula for molar concentration is that molar conc is equals to mass conc over molar mass. Or some people can write it as conc in mole per dm cube is equals to conc in gram per dm cube over molar mass. So my molar concentration now is already derived from the first question, which is the I, and that is 0.102 mole per dm cube. My mass conc now is the one that was immediately just derived so far, that is 10.1, so over molar mass. So from there we make molar mass the subject of the formula. That means m dot m will be equals to 10.1 divided by 0.102. So at the end, my molar mass is 99.0. You can see again, I also made the molar mass here. I gave the answer in 3 significant figures. It's very important that you do that, because sometimes when you do not give your answer in 3 significant figures, Waec would not score you. So my molar mass here is 99.0 gram per mole.